So in the previous video we got to know how we can represent a graph. So we got to know that we can represent the graph in two ways with the help of adjacency lists and adjacency matrices. So we will be implementing adjacency list representation. So what we need in adjacency list representation, we will use an array of linked lists, right? So we will be using an array of linked list, and the size of array would be equals to the number of vertices, and each entry in array I represents the linked list of vertices adjacent to the ith vertex. This we know from the previous video. So how we can now implement it in C code, right? So we would be needing three structures for maintaining this. So the structure of graph would look like it would contain the number of vertices that we will be having in our graph, and it will also contain the array of linked list, and each linked list would contain a pointer that will point to the head node of a linked list. And what linked list would contain? Linked list would contain two fields. One would be data field and another one would be the pointer to the next node. So for example, if this is the adjacency list representation of a graph, these would be the nodes that we would be needing and that linked list would contain. And this is the array of linked list. So we would be needing three structures, one for the node, one for the list, and one for the graph. Now this would take care of all the structures that we would be needing in our graph. Now how we can access the fields. So for example, if we want to access the field corresponding to the array index 1, let's say if we want to access the linked list corresponding to the array index 1, so what we will do, we would go to the graph and access its array field array index 1. If we want to access its array index 1, now we will go to the head node of that array, that linked list. So we would access that head like this. So this would give us access to this linked list. So now we will create a graph. So we would make a function for it. So it would take as an input the number of vertices in the graph. So first of all, we will allocate a memory to the graph dynamically. So this would return to us a pointer that would point to the graph. And now we will set its data fields. So what are its data fields? So these are the number of vertices and an array of adjacency lists. So what we would do is we would set as number of vertices data field as number of vertices that we took as an input, and its adjacency list array of adjacency list. Now we would create an array of adjacency list which will contain this, which would have the size as the number of vertices. So this line would create an array of adjacency list, and the size of array will be the number of vertices, that is v in this case. So now we will initialize each adjacency list as empty by making head as null, because at first we don't have anything in the adjacency list. So after this, what we would get as, if we have given an input as 5, so this graph would be returned. What kind of graph would be returned? It would contain these array index 0 to 4, and each array index would point to a list, empty list, that is null, because at first we don't have anything in the adjacency list. So now we will be creating a function that would add an edge to the graph. So what it would take as an input is the graph to which we want to add an edge, and from which vertex to which vertex we want to add an edge. So in this case we would be adding an edge from source to destination. So what our edge would look like, our edge would look like this. There would be an edge between source and destination. So in our adjacency list representation, so we would create a node corresponding to dest and we would attach it to the array index source. That would be a adjacency list corresponding to a source. So what this function would do is it would create a node corresponding to destination data field, and it would go to that source adjacency list and it would attach this node to it. So what this function it would do, it would create a temporary node with dest data field. This was a create node function that we have created. This was our create node function. It would create a node with the input and it would set its next to null. So we will create a node. Now what we would do, we have to attach this node to the source adjacency list. So what we would do is we would set its next to the source. So this line would go to that array source head and attach temp next to it. So this would be this. Now our new head would become this. So after this function, what this adjacency list representation would look like, this would look like this. It would be a node corresponding to dest data field. It would be attached to the source adjacency list, and head of that adjacency list would be the node corresponding to dest. So this is how our add-edge function would work. So now we will be creating a function to print a graph. So it would take as an input as a graph which we want to print. So what we will do is we will traverse all the adjacency lists from end to beginning. So we would traverse all the adjacency list from end to beginning and we would print all the data corresponding to each adjacency list. So what we would do is we would create a pointer named traverse and it would point to each adjacency list one by one. So at first it would point to the adjacency list corresponding to this array index. So it would print all the data that is attached to this linked list, that is attached to this adjacency list. It would print it, then it would go to the next index. It would traverse this whole adjacency list and it would print it. So what we would do is we would create a pointer named traverse that would point to the head of that adjacency list. While that traverse is not null, we will print the data and we will move that pointer to next till it is null. So this function would print the data for us. So this was all about the adjacency list representation of a graph. Now in the link description below we have that code. You can take a look at it.